Hello kids, you finished with IB3 and hopefully that went pretty well. You have homework for tonight, one problem in the book, page 142, excuse me, and then to create our little review book. Now I will have supplies in class tomorrow if you want to do your little review book tomorrow in class, but in case you're not going to be here, I wanted to make sure you had all the titles, because this little review book is due on Tuesday, the day before the test. So let me just make sure to write here. This homework is due tomorrow. Along with the handouts that I'm going to do in this lesson. Then the sub has for you matrix review. It's not a cumulative review, it's just some review. And your little review book. This is due Monday, and the little review book is due Tuesday. So, this is a picture of my fam a number of years ago, because this is Delaney. Oh, she is a junior right now. This is our 5th kid. This is our 1st kid, Dean. We call him D1. This is our 2nd child, Deanna. Dean is an electrical engineer in San Diego. Deanna was a mechanical engineer for Raytheon before she decided that she wanted to be an oncology nurse at Children's Hospital in Philadelphia. And this is D3, Drew. He lives in Brooklyn and he works for MakerBot 3D printing. This, of course, is Mr. Getz. And this is me. And then this is the 4th child, Devin. She is in college in Boston, and she is studying mechanical engineering with a focus on brain development. And of course this is Delaney, and this is the last one. This is Dylan. We call him D6. So yes, they all do begin with D's. D1, D2, D3, they're all 3 years apart. And so is D4, D5, and D6, all 3 years apart. And there are 10 years between D3 and D4. And notice that there are 3 boys and 3 girls. Very mathy. Math fam. So I showed you that picture because the first problem I'm going to do with you is a modeling problem, matrix modeling problem, that involves Drew, who is D3, Deanna, D2, and Dean, D1. So this is modeling with matrix, but it is matrix operations instead of the systems. So given that these matrices below represent the number of hours worked by the 3 people on different days in the week and the dollars per hour. Notice red, number of hours, blue, days, and green, dollars. So I want you to use matrices to calculate the total pay made by each of the 3 people for the 3 days. Now this is a very simple problem. I actually don't need matrices to solve this at all. But I want to show you how matrices can be used with much larger systems. So, I want you to think of this matrix. You can tell me its size. This is a 3 by 3 matrix, and this is a 1 by 3 matrix. But this is a word problem, so there are units on the matrix. So, remember, dimensions go row by column. So hopefully you'll agree that the 3 rows, the units on there are people, my D people, and the columns are days. And then my pay, my 1 row, this matrix, the 1 row is the first row, just the only row is pay, and the 3 columns are days. So this is a 1 by 3 that is pay by days, and this is a 3 by 3 that is people by days. Now, can I multiply these two matrices? And I say multiply because I have Drew, who worked 4 hours on Monday at $7 per hour, and $6, 6 hours on Tuesday at $8 per hour, and 6 hours on Wednesday at $10 per hour. So notice that math. 4 times 7 plus 6 times 8 plus 6 times 10. I can do this without matrices, but notice that matrix multiplication is not possible because the columns of the first do not match the rows of the second. What, oh what, could I possibly do? I wonder what could possibly come to my rescue. I hear a T word. Did you say transpose? I thought you did. So what if I do the transpose of this second matrix, where my first matrix now looks like 4, 6, 6, 2, 3, 5, and 4, 4, 2. And it is a 3 by 3 matrix that is people by day. But the transpose of this matrix, right, from left to right, 7, 8, 10, would be from up to down. And this is a 3 by 1. And it is now days by pay. So what happens here? Notice that not only can I multiply, right? The columns of the first now match the rows of the second, but what is my resulting matrix? Not only is it a 3 row by 1 column, but notice days kind of sort of cancels out, and I'm left with people by pay, which isn't that what I wanted. So I'm going to end up with a 3 by 1 matrix where this is going to be people, Drew, Deanna, and Dean, by pay. So how do I multiply? 4 by 7 plus 6 times 8 plus 6 times 10. So 4 times 7 plus 6 times 8 plus 6 times 10. Then 2 times 7 plus 3 times 8 plus 5 times 10. And then 9 times 7 plus 4 times 8 plus 2 times 10. What do I get when I'm done? I do that multiplication. So I have 28 plus 48 plus 60. So Drew made 136 over those 3 days. Deanna made 14 plus 24 plus 50. Now I'm reading this really small, so check my math. Deanna made 88, and Dean 63 plus 32 plus 20. Did I do that right? 115. Now this is a word problem, so answer it in words with units. And again, check my math because I'm reading those teeny tiny there. Deanna made 88 and Dean made 115 over those 3 days. So that is one kind of modeling with matrices that uses matrix operations. You had to use the transpose, the matrix occupation is a transpose, and then we had to use matrix multiplication, and then of course we had to deal with units and words that we hadn't done before. So if this was a problem on a test, the unit points are going to come in creating the transpose, showing me your multiplication, getting a result, putting your results in words. So this could be worth 4 marks or 4 points. Okay. Alright, so the next modeling I'm going to show you with matrices is with systems. So this is going to take, this is going from algebra world to matrix world. So as I read this problem, and I've given you a hint here that I've got 1, 2, 3 variables. So at Rockville they're showing Pocahontas for the Thanksgiving holidays. If you came dressed as a pilgrim, your ticket cost. So pilgrim cost. If you came dressed as a Native American, your ticket cost. If you showed up dressed as a turkey, your ticket cost. So the first thing I'm going to do right here is go down to define my variables and say, I'm in math class so I'm kind of boring and I use just X, Y, and Z. X, pilgrims, Y is Native Americans, and Z, turkeys. Now I want to relate variables. Relate means write equations involving those. So the first thing I noticed was cost. So first thing they started talking about. So every pilgrim ticket cost $12.50, and every Native American ticket cost $7 if I was dressed as, and every turkey, if I came dressed as a turkey, I paid $4.5, and that's got to equal some money. All of this is in money, so I'm looking for a total. Up, there's a total, but that's not money. Total money. Okay, so that's money. Now I have 3 variables. If I'm going to solve a system with 3 variables, I need 3 equations. If you have 3 unknowns, if you have 3 variables, you need 3 equations. Or you can't solve it explicitly for X, Y, and Z. So what is the next thing? I did notice a total of tickets. Total tickets. So that is pilgrim tickets and Native American tickets and turkey tickets in total. So that's 2 equations, so I only have 1 equation to go. So what else do I have? Oh, the sum of the number, so no cost again, the sum of the number of Native American, Y, and Pilgrim, X, was, that's an equal sign. It is or was is an equal sign, so let me write that down first. The sum of X and Y, X and Y, was 702 less than, so that's 702 less than would be subtract the number of turkey. Turkey is Z. Okay, so that means the sum, the number of turkey tickets is Z. The sum is the number of turkey tickets minus 702. So there is my relationship. I have 3 variables and 3 unknowns. So I'm going to group them into a system. Oh, that's terrible. There's my system of equations. And I'm going to use matrices to solve the system. So my setup, remember, is coefficient matrix times variable matrix equals awkward space, the answer matrix. And C inverse has to be left multiplied here, left multiplied here. That's going to get me the identity matrix times variables, which is going to get me just the variable matrix. Okay, by itself. So my setup, here's C inverse times my variable matrix. My variable matrix, oops. Sorry, hold on. This is going to be my coefficient matrix. Coefficient matrix times my variable matrix equals awkward spot, awkward space, my answer matrix. So my coefficient matrix is 12.5, 7, and 4.5. 1, 1, 1. Ooh, this is awkward. I need my Z over here. Oh, I know algebra 1. And I'm going to take this positive Z over here and make it negative Z. So my next one, 1, 1, and negative 1. The variables that I'm using are X, Y, and Z. And my answers are 151,924, 24,202, and negative 702. Then I'm going to left multiply here by C inverse. And these two will multiply together, and I don't have to see that, to give me my identity matrix times my variable matrix. I need you here to show me what C inverse is. So C inverse we're going to have a calculator to do this. In matrix 3, because I like to call it C for coefficient matrix. Notice I changed the order I made mine. 1, 1, 1, 12.57, and 4.5, 1, 1, and negative 1. I just switched the order of my blue and my red equation there. So that's in matrix C. So I want C inverse. So I hit Matrix C, I call that up to my home screen, and then I hit the inverse button. Enter. Oh, gross. So I hit math, fraction, enter, and I write down, oh rats, I guess I can't see all that at once, but I wrote it down. So that is -23. Oops, sorry. Yeah, so remember, mine's not going to match here. Oh, I should. This is annoying. I'm sorry. I can't handle it. I have to erase. So let me just do, sorry, so that my determinant, so that my inverse matches. Let me just switch the order of this. So I had 1, 1, 1, then I had 12.5, 7, and 4.5, and then I had these two numbers switched. And again, I only want to do that so that my inverse matches. So I need to see what C inverse is at least once. So use math fraction so you don't have to spend time writing all those decimals down. -23 over 22. Can you guess from all the denominators what the determinant was? I think this is 17. And when I multiply those together, so I hit second, so I want to multiply this, I want to multiply C inverse times the answer matrix. So notice, this is a 3 by 3 times a 3 by 1 is going to give me a 3 by 1 answer. So write down the so we're going to write down 2480, 9270, and these are just numbers right now. 124.52. This will get you a lot of points. There's going to be points for defining the variables. There's going to be points for coming up with this entire system. There's going to be points for this entire setup where I can see C inverse times your variable matrix times your coefficient matrix times your variable matrix. I need to see C inverse written out once. You don't have to write it out again here, but I have to see that you know to put it on both sides. So C inverse goes here times your answer matrix, and then there's going to be a point for the matrix answer, and then you do not need to take this answer back into algebra world. I didn't start in algebra world. What world did I start in? This is word world. So if you started with words, Make sure you answer with words and units. So you say, the question was, how many of each kind were sold? So there were 2,480 Pilgrim tickets sold. There was 9,270 Native American tickets sold. And there was 12,452 turkey tickets sold. And of course, if you want to check your work, you can go back to the beginning and add the number of Pilgrim and Native American tickets together, and then see if the turkey tickets, 12,452 minus 702, is the same amount. You can add all three numbers together, see if you get 24,202, and you can multiply by the cost and see if you get $151,924, and you will. So the book problem practices one of these. One of these will be on your test, along with the modeling that I did in the previous problem that just used matrix operations. So there's a picture of us, same family, same time, just being all goofy. Love my fam. And now I want to give you the little book instructions. So remember, you can do this tomorrow in class, but if you're not going to be in class tomorrow, you need to get a colored piece of paper preferably, but if you want to do it on white paper, that's fine too. Unit 3 matrices. I put all your pretty simple operations here, your adding, subtracting, and scalar multiplication. Make sure you know how to do this both with and without a calculator. And then of course, again, for adding and subtracting, make sure you know the rules. When can you add and subtract matrices? And make sure if you're not going to add or subtract, you need to say why. Same with multiplication. What are the rules for multiplication? Right? And then examples. In practice, remember, you also need to do this both with and without a calculator. I cannot answer calculator questions during the test. Oops, sorry. So determinants, you need to know how to do 2 by 2 and 3 by 3 without the calculator. And then also remember that some of these, sometimes there are numbers in there, and then sometimes I put variables inside. Right? Make sure you practice the nasty ones that I've done in class and for homework. The identity and inverse for additive. The additive inverses and identities we don't use as often as we do the multiplicative. Make sure you know the multiplicative identity and the multiplicative inverse. Matrix equations, you had handouts and Khan Academy videos and practices of solving matrix equations without inverses. That would be something like matrix A plus 2 times, this matrix 3, 4, 5 is equal to 7, 8, 9. Solve for A. And then matrix equation using inverses would be something like A times 2, 4, 5, 7 is equal to blah, 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 blah. Then solving linear systems, going from algebra world to matrix world. You need to know how to do 2x2s without a calculator. And any 3x3 or larger will be with the calculator. And then the IB matrices, right? The handout with the IB matrices, look at all of those. Right? These were all kind of like the curveball ones, kind of like the weird ones with lots of variables and stuff like that. And a determinant equal to 0, you know, remember that? Like, or I had one with a P inside and it said, you know, you had to use a 3x3 determinant to solve for P. That also would be, this would be on the non-calculator part. And then of course the matrix world problem, matrix word problems. Those are the two that we just did, right? The ones that are matrix operations, that's the D1 through D3 problem, and then linear systems. That was the Thanksgiving problem. Okay? So again, remember, this is not due until Tuesday. Tomorrow I will check the 2 handouts to make sure you did them with this video. The Deanna and Drew D1 through D3 one and the Thanksgiving problem. Those 2 handouts I will check tomorrow along with that book problem from page 142. That's all that I will check tomorrow. And the matrix review handout is not due until Monday. Alright, I will see you tomorrow.